So we're getting ready to coat our set of Zenith carburetors. I've plugged off some of the stuff where I don't want paint to go down, so I've got my idle jets plugged, mainly because there's a seed in there. I don't want the paint to break off. And I've also here on our vacuum tubes, I've capped these because I want to keep that brass finish. Not worried about anything that makes it into the bowl area through here or down into the main jet wells either, because they're a self-contained jet and this paint is fuel safe. For this set, what we've decided to do is screw the tops onto the bodies. That's because we didn't want to paint these surfaces on both, and I think it's the best way to deal with it. That way they're going to be protected and it should come out how they are going to look when they are reassembled. So I'm going to get ready and mix up some cerakote and paint these and bake them. Okay, so we've got our hardener and cerakote mixed. I'm just going to strain that into a small touch-up gun. So I'm just cleaning out my mixing tube. And we got plenty of time. The hardener is good for a couple hours. So we're just going to bake both the carburetors now for an hour at approximately 300 degrees. I have our carburetor bodies out of the oven with our Cerakote green finish. This is to replicate the original finish that these used. Slightly different look, but I think it comes out quite nice. So I've already got one done quite a way, and I want to show you guys the process on this one. But what I want to do is go ahead and install all of these studs first. You can see I've just started these finger tight, and I'm going to use my stud installer just to wind them down. And I like to do it like this first just because it's easy to hang on to everything. It gives me a good purchase. So I'm going to get the studs in, then we're going to pull the top off. We need to clean everything. I'm going to run an 8mm ream through my throttle bushings just because we didn't do anything with masking this area off. I want to make sure that I remove the Cerakote from down in here, and this is the easiest way using a chucked ream. And then I'll give these a light hone. We'll get our throttle shafts back in and throttle plates in. All right, all my studs are in. I'm going to take out my paint screws, and these are just 2 screws that I use to hold the bodies together. Okay, and there's my top plate off. So here's our body. So first thing I'm going to do before I clean is I'm going to do my throttles. So for that I have a standard 8mm chucking ream. And I'm just going to very carefully feed this through, and I want to feel it. I don't want to be any angle, I want to be nice and straight. Turn it around, get the other side. Okay, next I'm going to take my ball hone. I'm not trying to change the size of these bushings. I've already measured everything, and from a pin fit standpoint, everything's right there. All I'm doing is cleaning out the little bit of Cerakote that we got in. Then we have our throttle shafts that have been cleaned, mic'd, dressed. I've already retapped the threads on them. One thing I do want to do is I want to take my small file in here and just clean these surfaces. This tends to sometimes pull a little bit of thread up into here, and it's better to check it with a throttle plate while it's out of the body rather than trying to do it while it's installed in the body. Next thing I want to grab is my 2 couplings, because these all have to go on at once. and these often will get burred up, like this one. Lets me come in one direction but not the other. It's nice that way, but this way we've got a burr that it's getting stuck on. And I want to go ahead and flush out everything. So I'm just going to use some brake clean, flush through all of my ports, make sure I got good flows through everything. Main jet areas. All of my idle jet areas and fuel pickups. Just want to get any of those remnants of vapor blast, machining, anything loose out of there. So everything is clean, aired out, all my passageways are clean, ready to start putting things back together. Now, Zenith versus Weber use 3 individual throttle shafts, so I want to start with my center throttle shaft. And the one important thing is, well, one, I've also honed these to make sure they slide through very nice on our couplings, but you want to make sure you get the couplings in when you set that center shaft before you put the throttle plate in. Otherwise, you won't be able to get them installed. So I'm just going to lubricate our bushings, and as well as my shaft. So what I want to do is put my first bushing in, and I'm going to slide it all the way to one side and put my second coupling in. And then we're just going to let those sit right there. I'm going to grab my throttle plate, and on the Zeniths, they have a machine slot here which makes the activation to the progression ports very, very quick. And what this does, by removing that material, it exposes those ports a little faster. This slot has to face these progression ports. So I'm going to put this in like this. So the next thing I need to do is I need to true up my throttle plate. Our slot down here is kind of offset, and the progression ports, which are right here, it's not all lined up with it. That also means it won't be sitting in the bore perfectly in the right position. So I want to give that a slight turn, just like that. And what I'm looking at is down inside here. So once I've got my throttle plate aligned, I am going to put some red Loctite on it, keeping the plate closed, and tighten my screws. Okay, everything should move smoothly. Now we're ready to move on to the next one. Normally what I'll do next is going to be my front. The part numbers on a Zenith is going to indicate which is the front side of the carburetor. And I pre-assembled the throttle lever, and this little wave washer here is really important. On the front throttle shaft, when you slide this in, we're also going to have a little spacer that goes right here. And what this is set up, this wave washer creates some spring on the throttle shaft that allows it to move. And then we're going to have another spacer here, and then this coupling is going to come up against it, and that's going to control the movement in that front shaft. This is because where the throttle link pushes on it, it can tend to try and push that shaft back and forth, so we want to control that movement on the front barrel. The other two barrels are just going to be the same. You'll see a space right here on the throttle shaft, and there is no other spring washer like this or a spacer on this side. With this one, I've lubricated the shaft. I'm just going to put my spacer in right now, And I've just got this up. You'll see how it springs back. Once I get the throttle plate in, we'll set the throttle plate, make sure it's nice and square in the actual bore, and then I'll get this somewhere in the middle. If we're pushed all the way in or all the way out, the throttle's going to want to bind, so we want to find the middle point. The lubricant in there, but I need to set my throttle plate first. So now I've got my throttle plate set up correctly in the bore. I need to set my throttle shaft. So what I usually like to do is, if I move it back and forth, you can see that it can go in a lot of different places and still the screw line up with the holes in the throttle plate. I usually like to get a little bit of a preload, about half the amount of the spring washer will allow. So to do that, I'm just going to get a screw in and set with some Loctite on it. Then I'm going to take my throttle while it's still loose, push it all the way one direction, all the way back, find the sweet spot, and then tighten that down. And then our throttle should work nice and smoothly. We're going from the stop in the front to the stop in the back. So lastly, with my throttle closed, I want to go ahead and set this coupling, and I usually like to put the set screws on 45-degree angles. I don't want to force this really tight against here, because then that can cause the throttle to bind. So I just want a light pressure between the spacer and the coupling. Go ahead and lock that one down. And that's too tight. When I open and close the throttle, it's not allowing it to move. So I'm going to loosen it off. Still too tight. Okay. Close this one. Okay, so now I got two throttles connected, and I've got to bring in the third one now. On the end shaft, we're going to have a little spacer that's going to slide on. Then our spring purchase. I need to check if this is going the right direction. I like to use a Schnorr washer instead of the lock tabs, and a nut. We're also going to have our return spring. So I want to look at which direction my throttle is going to activate, which is this direction. In the end of my carburetor body, there's a little hole right there where this spring is going to locate. Let's just put this on lightly for the time being. Lubricate it. And as this slides in, it's going to pick up and lock the spring in right there and rotate to a preload. So when the throttle plate goes in, that throttle shaft is going to be under spring tension. And this is going to help, because right now if we open the throttles, we can set them pretty much anywhere and they won't close because there's no spring pressure. This is going to give us a spring pressure, and then it'll also be aided by a secondary spring on the actual throttle link. So before I go too far, I want to tighten all of this on the end here, because if I install my throttle plate and tighten it up, I run the risk of pulling the plate into the side of the throttle bore, which will cause it to bind and wear the plate out. Okay, let's make sure everything is tight. Okay, now my throttle's springing back, nice and smooth, no sticky spots, all the way till shut. I'm just going to add idle stop. Right now the throttle plates are all sitting against the throttle ball. So I got the spring and the idle stop screw. And what I'm watching when I do this is I want to expose just the first progression port. So I can see I've got 2 ports exposed there, 2 ports there, and only 1 port there. So there's some timing issues here that I'm going to need to deal with. So right now I want to set this one. So I have just the 1 port exposed. On this very back one I've got 2 ports exposed, so there's some timing issues there as well. Okay, so I corrected my slight alignment differences between the progression ports with just slight adjustments on each coupling. Starting from this side, I worked through, loosened this screw, adjusted this plate, tightened this screw, then the same on this side, loosened this screw, adjusted it slightly. So now everything is nice and in alignment. I'm going to put in my last retaining set screws and move on with the rest of the carburetor. Alright, so now we got our throttles all assembled. This is probably one of the biggest parts of the job with reassembly, is getting all of these in. I'm just going to go and start getting all of my brass back into the carburetor. So my progression plugs. Grab my main jet holders and my main jets. Then your actual main jet is going to screw in on the very end. These are a 110 on the main jet. Then it's very important too that you tighten these. When I pulled this carburetor setter down, I found 4 out of the 6 main jets were loose in their holders. And that'll cause fuel to leak past the threads and be an unmetered fuel, in which case the main jet is useless. Drop those in. Since I'm laying on the side, I've got new idle jets for these. These are a 47.5. Can go ahead and drop them in. And we just want to lightly seat these. You can crush these, and I've seen them over tightened before. Bowl plugs. Okay, so I'm going to install my air bypass screws. Now these from the factory have like a little piece of Delron that is installed in the screw that is acting like a nylock. Unlike Weber, these don't use a lock nut, and there's not enough space to screw a lock nut on and then lock it against the body. And short of buying a new screw, you can't get them. You can't just buy this little piece here. So what I normally do is a little drop of blue Loctite on each one. Blue will allow me to break it loose in the when it's on the engine and it's not so tight as to be a red, and just create enough tension to where I can still adjust it but they won't vibrate out. So with these we want to screw them all the way down and just let them lightly seat. You don't want to crank them down super hard. Okay. So this hole right here is the mixture screw adjustment for the air bypass system. Same thing, has a piece of Delron in there, and if you just screw them in, these are usually pretty loose. Same thing, just a little bit of blue Loctite. And we want to treat this like any other mixture screw when we're doing a base set on the bench, in that I'm going to screw it all the way down till it seats. Right there. And then I'm going to back it out 2.5 turns. We'll do our final setup on the test engine for that system. I'm going to flip the carburetor over now, and this is all of our accelerator pumps right here. Before I can put on my cleaned accelerator pump faces, I've got to go make sure they're flat. So I've got my piece of glass that I know is flat, a piece of 80 grit, and we just want to go very quick figure eights, make sure all of these are nice and flat. Yep. There we go. All right, so the trick with these is you got to make sure the spring, not so much in the outer ones because there's a little retainer, is sitting on that spring plate on the actual diaphragm. Then with the first screw, I'm going to line all my holes up, keep everything nice and loose till I get all 4 screws started. So with everything tightened down, the pump should move nice and freely. I'm just going to put the other 2 on. I've cleaned the threads on our accelerator pump linkage, and I'm just going to lubricate. I've already lubricated each of the studs, and go ahead and get these screwed in. With these, you just want to start them for right now. You don't want to screw them through too far. Normally all I want to see is about that much sticking out at first. We'll adjust everything once it gets on to the carburetor. Also, I've got our roller off the front here. This is our missing Teflon. I went ahead and cut a piece from our Teflon. And what I do first is I'm going to put it into the roller, although this one needs to be cleaned first. What I want this to do is take a set. So when I install it onto the shaft, I'm not fighting too many things at once to get the roller on and deal with a piece of Teflon that needs to be round, not straight. Now you can't install a piece of Teflon onto the roller and then slide it in because there's this little lip right here. So what I have to do is wrap the piece of Teflon around here and then work my roller in. The thing that makes it a little bit of a challenge is inside here there's not the greatest lead in into this bushing area. So you want to just work it with your screwdriver until you can get it to come on and seat, and then rotate it around. Finally, I'm going to give it some light lubrication. Install the circlip. We're ready to go. Now, when you are installing this, there's a little spacer section. You want to make sure that spacer faces this arm so it kind of holds that roller off of there. And it usually won't sit on that circlip. There'll be a slight air gap there, which is perfect because we want this to move freely. Next thing we want to make sure is our bearing surfaces here are lubricated and move freely. We don't want any binding in any of these components. Lubricate the end bearing. Make sure everything moves freely. And I'm just going to sit this on here while I get my bolts. Okay, when you tighten these down, you always want to make sure that this shaft still continues to move freely. Next, when it comes to adjusting this little screw right here, so if I take my small screwdriver, if I change the angle of this, it will actually move this entire rod at the same rate. Each one of these screws will individually adjust against each individual accelerator pump so we can balance them. This screw will change all of them. So with our throttle set roughly at idle, what we're looking for, and this one's actually pretty close, is we want these little levers right here. We'd actually kind of like them to be straight up and down, or 90 degrees. If you were thinking coming off here and up, a 90-degree L shape. And then to start, I'm just going to screw each one of these down till they just contact on those accelerator pumps. So working on the inside of the bowl, this little tiny jet, and there's a little tiny hole there. This is the fuel jet for our deceleration system. It needs to go down into that little tiny hole right there. And this one's really easy to mess up. So I kind of want to just slide it down there, get it sitting in there, and then use my little jeweler's screwdriver to screw it down and lightly seat it. Next, these have individual accelerator pump check valves. So there's going to be 3 of these, 1 here, 2 in this bowl. I'm going to go and get those in next. So I've got all 3 check valves in now, 1 on this bowl and 2 on this side. At this point I can drop my chokes in. Now the next stage of this is a little bit of backwards and forwards. I need to get my little accelerator pump weights. These do 2 things. They act as a check valve. They also act to accelerate the fluid around them. We're going to drop these into our accelerator pump holes and just let them drop and seat all the way down. And then I'm going to grab my accelerator pump nozzles, make sure they all flow, which they do. And these can be a little tricky on these carburetors. Sometimes these O-rings will tend to want to leak, and you'll have to kind of go in and out with them. A little bit of silicone grease on each one. We will be pulling these out. I'm testing the delivery rates and setting the delivery rates without the auxiliary booster in there, because with the booster you can't get the measuring vial around and underneath the nozzle to measure the fuel flow. Okay, I'm just going to put my carburetor stands because I need to be able to activate the throttles. So right now our throttle is functioning. So I'm just going to bleed the air out and get these squirting. Okay, you can see right here this one is leaking. So a lot of the times I can just pull it up, get it just the right place. Nope, still leaking. Have to play with O-rings. One thing you got to watch is when you work the throttles, they will tend to lift up. So on these I am looking for around 0.4 of a cc. Right now we're running at 0.35. So I'm just going to adjust this in a little bit. A little bit much, went up to 0.5. A little bit too little. Right on 0.4. Once it's set, I'm going to hold the screw and lightly lock that down. Alright, so now I've set everything and I've got my 0.4 of a cc. I'm going to just carefully pull these out. I want to keep each one with the cylinder that I just set it up with. So I'm just going to assemble our emulsion tubes into our emulsion tube holders, put the air correction jet on top. Okay, so these are an interference fit. And I'm just going to gently hammer those in, just like that. Alright, so now I'm going to put my auxiliary boosters in. I need the little retaining clip, drops in on that side. Screwdriver, hold it back. And we want to make sure that the open slot faces our main jet stack. Okay, now I want to return my accelerator pump jets to their original holes. Looks good, no leaks, ready to move on. I'm going to move on to my deceleration valve, and on these we purchased new center discs and a new spring, and this is a little check valve system with a diaphragm that sits right here, and this is what picks up our idle speed. And I'm just going to set my spring and my disc valve. So these little M4 screws hold the assembly together, and then the M6 will clamp the top onto the body at the same time. I just want to make sure that everything is lined up. Use my screws to keep everything aligned. Okay, and then this is our idle control for our deceleration system. A little bit of blue Loctite again, just because the Teflon. And I'm going to treat this like a mixture screw. In there I will screw it all the way down till it lightly seats and back it out 2.5 turns. And I just need an O-ring. Okay, there's our deceleration valve. We've still got to plumb our hoses and our pipes. I need to make one pipe. I think it's on this carburetor on the left side, just because it was missing one of the brass. So I have a stick of just raw tubing that we're going to bend up and make a new connection pipe. So I'm going to put the top plate gasket on. Once again, our accelerator pump discharge nozzles are in the way. So here's my gasket. You've got to be careful, make sure that this side of the gasket is here and all of these holes are exposed. We have our auxiliary, we have our air bleeds for our idle jets, and this is our auxiliary air bleed. We've got to be very careful, make sure that that little piece of the gasket is punched out. Feed these down over here. And I find if I use the top plate to help install that gasket, less chance of it ripping. Now I need to check my accelerator pump nozzles again after I reinstall them. Great, nothing leaking, everything looks good. All my nozzles are squirting fuel. Nice. So the next step is to assemble my top plate. We've already put our studs in. We did that when the bodies were still connected. First, I'm going to start by reinstalling the vents that we took out. And these are like driving a nail in. We want to line them up in the hole. And just drive them until they're flush. Oops. All right, next I'm going to reinstall my floats. Lift this up here. I'll put in this screw first, just because I can move the float around and I don't have to pull the pins, and then I'll come back and put the second screw in, and then we'll put our needle and seats in. Okay, and then the same for the second float. I want to do my inside screw first while I can lift it up. So that's my floats. I'm ready for my needle valves next. So when it comes to setting the float heights on these carburetors, these are a little different than, say, setting up the Webers. So normally I like to start with a 1mm fiber washer. And we're just going to screw these in, make sure it's going to sit on there nicely. On the bottom side. And what we're looking for is our float to sit parallel to the top plate. tighten that down. Now, one thing that we want to be careful of is in the top of the needle and seat, you have this little check valve. And right now, if we look at it, it looks like the float is sitting down too low, and it is because the weight of the float is completely compressing the spring and ball. So I'm going to pick it up, and I'm going to bring that float down just until it starts to compress the ball valve, and look at my float height. And that's sitting right about where it should be. I'm going to sit my top plate on. Make sure it locks all the way down. Put all my perimeter screws in. So when we're screwing these down, unlike when this engine came apart, these should screw down very, very nicely and smoothly without any tight spots. And as a best practice, I always make sure I get all of my screws in and just snugged down a little bit before I actually tighten. And then on this front one here, we need to put our spring purchase on. Let's see, which one is it going to be? So there's two different spring purchases, a long one and a short one. You have a little short stick out on the one carburetor. On the second bank you have a long stick out, so the long spring purchase goes with the long stick out. Alright, so I've got all of my screws nipped down. Now I'm going to tighten. So I want to just do my standard crisscross pattern when it comes to torquing these down. Okay, everything's nice and tight. I still have a little bit of brake clean in my bowls, so I'm just going to make sure my throttles are squirting and I don't have any leakage. Everything looks good. So our bowl plugs, just like a Weber carburetor, are going to go straight down on top. Sorry, needle and seat covers, not bowl plugs. And I have a fiber washer in here. Go grab a socket. So I'm just going to tighten these down and tighten them up. So just always checking, making sure everything's moving smooth and doesn't feel rough anywhere. If we look at our accelerator pump circuit, you'll see when the pumps bottom out how this spring system here works and allows that arm to deflect. So we want to make sure that everything is working on that side. So these are our deceleration system air pipes, and you'll see there's two of these pipes, and we only had one of these, and the carburetor came in with just a piece of flexible hose that connected it like this. And this will work, but I'm going to try and reproduce this one. This is the shape of the missing pipe that we have. This one hooks up right here, and then just uses short pieces of rubber hose to connect it. So we're going to try and duplicate this. The brass that I was able to purchase didn't have a thick enough wall, so when we tried to bend it, even with filling the tube with some sand, it still wanted to kink. So I just used some 6mm steel tubing, and we'll just go ahead and plate it. Deceleration valves get their vacuum signal through a solenoid on one carburetor that's screwed in right here, and then it tees off onto these two vacuum pipes. This pipe goes to the decel valve on the other carburetor. So what we've got to do here is, here's our vacuum pipe for this side. This is connected by a piece of 3mm cloth braided vacuum hose between the two carburetors. But I need to feed that through and around the throttles. And then this vacuum connection is going to come up here. We use our little M6 banjo bolt, 2 new copper seal rings. You want to do this before you've got your pipes installed too. And then one of the things that I want to make sure is I don't want to have this sitting on that throttle link down there. So I want to make sure I lift it up and kind of balance it in the middle of the two spaces there. Okay, so on the back side, now we're going to have our vacuum pipe, and this is when it's on the engine, it's going to go back and connect to a little T-fitting right here on this section. When it comes to installing the solenoid for the deceleration system, which is this, the most important part and one of the most commonly forgotten parts is that it has to be a little gasket that goes on the end of that solenoid to seal it. Now, a lot of the time this gasket doesn't come in the kit and you have to make it. I just stamped this one out of an existing washer that I had already. And then I'm going to install my gasket into the body first and make sure it's lined up all the way down the bottom here, and then put my solenoid in on top of it. Just going to put all of our vacuum pipes on next. So often in the kits, when you buy a repair kit for one of these carburetors, they'll give you a lot of different O-ring sizes. This one's typically used for accelerator pumps, but here's the two different sizes that are available for the mixture screws. What you have to do is measure the inside groove and the outside, and then measure how thick the wall thickness is to find the right one. In this particular one, we're going to be using the very smallest one. And then always with any O-ring that has to fit inside of a shaft and slide freely, I always put a little bit of silicone grease on it like that. All right, so I'm going to put our mixture screws in. This is almost one of the last operations before this goes onto the test engine. And these are like any other carburetor. I'm going to seat them, back them out 2.5 turns to start. That's just a starting setting too. When it gets on the engine is when it will actually get changed. Seems that a lot of people get hung up on that setting. So the way this system is going to work is we're going to put a T into the system and then use some little 3.5 vacuum hose is going to connect, and then this connection will connect to our other carburetor once it's mounted on the engine. All right, so before I put these on, these are a cast fuel fitting. What I want to do is just flatten this. So I've got my sheet of glass, my 80 grit sandpaper. And we just want to make sure that's nice and flat. All right, so all we got left to do on this carburetor is put our fuel line couplings in. These are directional, so this diameter here is different than this diameter here. The washer for the bolt end is a slightly different diameter on the OD and the ID. So the ID is slightly bigger than this one. So we're going to bring our bolt in from the small ID on the fitting. Our filter goes on next, followed by our washer, and then we're just going to screw these into the body. Normally what I like to do is set the back one on first, like that. Just going to sit this here so I can measure my fuel line, cut a piece of fuel line. You want to allow room for the ferrule, so I'm going to say 42 millimeters. And then I can pull this off. On our pass-through fitting, the end with the bob is going to face out. That's where our fuel line from the vehicle is going to come in. And the smooth end is going to face the other smooth end on this fuel fitting. Same thing, this is have two different IDs. We want the small ID facing out. Banjo bolt, filter assembly, and the washer is going to go on. So all I got left to do is tighten these up. This carburetor is ready to go onto our test engine. So when it comes to setting up a set of Zenith 40 TINs, there are two settings. There are the base carburetor tuning and balancing, and then there is our deceleration system. So these are set up independently. First I'm going to set up carburetors, then I'll come and I'll set up my decel side of things. So let's go ahead and get it started. I've already put a little bit of fuel to it. I know my accelerator pumps are working. Fuel first. Okay, crank it for me. Just a second.
Ready?
Don't sweat it. Okay, crank it. So I've got my basic tune and balance set side to side. I'm at 5.5 kilograms of air per hour. There's a little bit of coughing. Part of that is this motor wants a lot more fuel than these carburetors are jetted to supply. And that's because this is a high compression 2-liter T motor with a set of E cams in it. So you can hear a little bit of coughing back through the carburetors. Not too worried about that. A stock 911T that this carburetor is going onto will not experience those issues just because it'll have slightly lower compression and slightly less fuel requirements. So now that we've got carburetor's base set up, the next step is to set up our deceleration system. As I said before, our deceleration is vacuum operated, so we have our vacuum solenoid right here. Now, normally in the car, over here on this intake manifold, you'll have a bracket coming off with a micro switch. And this adjustment right here on this screw is when you are set at idle, once both carburetors have been balanced and are idling at 850 to 950, you want to screw this down until you hear the micro switch click. What that does is it is attached to a transducer relay that is attached to the tachometer. As soon as the engine goes above 1800 RPM, it arms the relay and says, okay, get ready. And then when it sees the throttles closed and the RPMs above 1800, it will activate this solenoid over here by supplying 12 volts to it. What that does is allows vacuum to flow from the carburetor body through these pipes to both of our decel valves, and it's a timed reaction. So the relay will hold the vacuum for a set time period until it sees the RPM drop below 1200. And the whole purpose is it allows these to idle up and provide a fuel mixture and a slower return to idle, less chance of stalling, as well as better tailpipe emissions without just dumping raw fuel into the tailpipe. I'm just taking power from my starter motor, and when I apply it to the solenoid, I can hear the solenoid click. So for right now, this is going to be our relay. Now, all of the airflow is going to be coming through the center barrel, through this barrel and this barrel, cylinder 2 and cylinder 5. This is another diagnostics tool. If you ever have a set of these carburetors on a car, you're trying to tune it, you do cylinder 1, you got 5.5 kilograms of air per hour. Cylinder 5, you've got 10. Cylinder 2, you got 10, and the rest of the cylinders are at 5.5. Means this vacuum system is activated, and this deceleration system is now supplying air, and it's drawing it all through this center barrel. I have had people call me up and say, yeah, the throttle plate's burned out on the center cylinders on both sides, and that has not been the case. It has been the decel system. So when you see high airflow there, you'll know what it is. I'm going to start the engine. Same thing, I'm going to let it stabilize. We got a bit of warmth into the motor now. It's fairly stable. And I'm going to set these up by energizing our solenoid. I want to match my airflow from side to side, so I'm getting the same amount. And I want to see around 1100 to 1200 RPM on my tach. So my tach's going to be right around here. To adjust airflow, this screw right here is going to control the airflow going into the barrel. And then we are also going to have our mixture screw. This is, we need to supply a little bit of additional fuel. Our throttles are going to be closed, so it's going to be a high manifold vacuum underneath the throttle plates. So there's a small jet that we saw in the fuel bowl, and this is a fuel mixture screw. Same thing as setting any other mixture screw. I'm going to adjust it for the highest idle, and then tune my idle speed from there. Okay, so once again, this engine is not that happy with these carburetors, mainly from a jetting standpoint. A little bit harder to get it to flow. I had my final balance on these was 9 kilograms of air per hour. And what we're looking for is that 300 RPM, 2 to 300 RPM increase when power is applied to the solenoid. That opens up both of our solenoids. And then our final fuel adjustments are our mixture screws right here. I didn't want to pull this one out, put a little bit of Loctite and just reset that, only because this one's a little on the loose side. I don't think it got quite enough blue Loctite, and I don't want it to vibrate on the car. The other thing you want to make sure is that the carburetors return nicely to idle once you release power. So I applied it a couple of times once I got it set, and then made sure that it came down without stalling. So that wraps it up for these. I got a minor fuel leak here I need to address, same as on the Webers. These are always a little bit of pain in the butt getting this fiber washer to seal. Sometimes it's got to get wet with fuel before you attempt to it. So I'm going to retorque all of my fuel line fittings, have a final look over the carburetors before I pull them off the engine. But all in all, everything looks like it is working the way it should do. I got good mixture control all the way along. My primary mixtures, my deceleration system is functioning the way it should, and car starts up, runs. A little bit small for this engine, but all in all, good.